Hi, we will solve this problem. Limit sine 3x plus a minus 3 sine 2x plus a plus 3 sine x plus a minus sine a upon x cube. What is this limit? Now, we understand a simple formula which is limit sine x upon x as x tends to 0 is 1. Now what we will attempt to do in this solution is to reduce this expression in this form or related form so that we can use this equation. And to begin with, we will have to club these four terms. So we see there are three common. Here there are 3 and here there are 3. So we club these two terms and we club these two terms. We club the first term and the fourth term and the second term and the third term. So now what happens when you do it? We get, suppose this limit is L. We say limit L is equal to L. L is equal to limit sine 3x plus a minus sine a okay, we've clubbed these two. Minus 3 sine 2x plus a minus sine x plus a. And this whole thing is divided by x cube. Right. Now we use the trigonometric identity, a formula we have learned in trigonometry. It is sine of c minus sine of d. Okay, sine of c, I will write this in yellow. The formula is sine of c minus sine of d is equal to 2 cos c plus d upon 2 sine c minus d upon 2. Right. Now in this case we will say 3x plus a is c and this is d. Whereas here 2x plus a is c and this is d. Okay. So now we use this formula to simplify this expression. So we get this, we arrive here, 2 cos 3x plus 2a upon 2 into sine 3x upon 2 minus 3 into 2 cos 3x plus 2a upon 2 into sine x upon 2. Now here we take 2x, limit 2 cos 3x plus 2a upon 2. We take this common. So that leaves us with sine 3x by 2 minus 3, this 2 is outside, this 2 we have taken common, So minus 3 sine x by 2. Minus 3 sine x by 2, and this thing we divide by x cube, our denominator. Now I will remind you of a trigonometric identity that you've done before. Now this identity, it says sine of 3x, sine 3x, sine 3x the sine 3x is equal to 3 sine x minus 4 sine cube x. Now while we are at it, let me also write the formula for cos 3x. The cos 3x is going to be 4 cos cube x minus 3 cos x. So we use the first formula, sine 3x, to break sine 3x upon 2 into 2 terms. Now let us see how this goes. This will be limit our first term remains untouched, that is 2 cos 3x plus 2a upon 2 into, now in place of sine 3x upon 2 I will write 3, I will use this formula, this equation, 3 sine x upon 2 minus 4 sine cube x minus 3 sine x upon 2, which we have already, minus 3 sine x upon 2, and we have the denominator like before, x cube. X tends to 0. Now you will notice that there is a 3 sin x by 2 here and minus 3 sin x by 2. So these two will cancel. Right. Now this leaves us with, so now we have limit 2 cos 3x plus 2a upon 2 into minus 4 sine cube x upon 2, this whole thing divided by x cube as x tends to 0. Now this, I think, we are more comfortable because we have a sine cube here and an x cube here. So what I will first do is I will take this 2 cos 3x plus 2a upon 2 outside the limit. I will separate these two terms. So limit 2 into minus, this 2 into minus 4 becomes minus 8. So minus 8 limit cos 3x plus 2a upon 2 as x tends to 0 multiplied by, now minus 4 we have already taken outside, correct? This minus 4 and 2 becomes minus 8. So now we are only left with sin x cubed 2. Limit x tends to 0 sin cube x by 2. Now this x cube I am writing here because this gives me a hint. I can write this as x upon t, and then it will be sin x upon 2 upon x upon 2 whole cube. So there is a hint here. Okay, these two, therefore I have clubbed, there is a cube here and a cube here. So I have clubbed these two, I have written x cube here. And that becomes equal to minus 8. As x tends to 0, this becomes cos of 0 plus 2a upon 2. That's cos a. Into limit sin x upon 2. I will write here x upon 2 cube. Now we have a correction here because we had an x cube in the denominator. In the denominator we had an x cube. Now we have written x upon 2 whole cube. So we have added 1 upon 8 to the denominator. Right? So to neutralize that, I will multiply the denominator by 8. So that this 8 and this 8 will cancel. Right? So x cube, x upon 2 whole cube into 8 as x tends to 0. Correct. Now that becomes equal to minus 8 cos a into this 8 I can take outside the sign, 1 upon 8 into limit sin x upon 2 whole cube as x tends to 0. Now as x tends to 0, this is of the form limit sin x upon x. Sin x upon 2 upon x upon 2. So this will be equal to 1. To 1. So what do we have? We have minus 8 cos a into 1 upon 8 into 1. This is 8. This 8 will cancel with this 8. So we are left with minus cos a. So our answer is minus cos a. Correct. Now let's see one more problem. Okay, our next problem is limit sin x upon x is equal to what? Now this exactly, it is not exactly sin x, it is this symbol, okay, is called the greatest integer function. The symbol, it is called the greatest integer function Now what it means very simply is this, that this function, it will take the value of the greatest integer which is less than or equal to x. The greatest integer less than or equal to x. Therefore, if I want to find the greatest integer function, x equal to 1.5, so this will be equal to 1, because 1 is the greatest integer which is less than 1.5. Correct? If I write my integers here, 1, 2, 3, so 1.5 is here. So the greatest integer less than or equal to 1.5 is 1. My answer is 1. Similarly, my greatest integer function less than is 2.01 is 2, because 2 is the greatest integer which is less than 2.01. If it is 2, it will again be 2. Why? Because greatest integer function less than or equal to x. Now in this problem we have to determine limit sign of x upon x, and x is the greatest integer function. Right? So how do we go about it? Now we know that for a limit to exist, LHL, the left hand limit, should be equal to the right hand limit for a limit to exist. For a limit to exist. Now in this case we have sign of now here we have limit. Now let us see what is the value of x, the greatest integer value of x, when x tends to 0, as x tends to 0. Alright, so now what we will do is, we will first create additional space for writing. Okay, then now x can tend to 0. X can tend to 0 from the left hand side as well as the right hand side. Okay, so this is my number line. My 0 is here. I have +1 here and -1 here. Right? It extends on both sides. Now x can tend to 0 from the left hand side. Now when x tends to 0 from the left hand side, the greatest integer which is less than or equal to this x. X is here. X is in this region. So the greatest integer which is less than or equal to x is -1. Okay. Now let me circle this. Now when x tends to 0 from the right hand side, okay, come here, my x is here. Now the greatest integer which is less than x or equal to x is 0. Alright, so now if I have to find if I want to find limit sin x, what if I left hand limit sin as x tends to 0. Now as x tends to 0 from the left hand side, minus. As x tends to 0 from the left hand side, what do we have? We have the greatest integer less than 0 will be minus 1. So this is equal to limit sine of minus 1 upon minus 1. Okay, as x tends to 0. Now limit sine of minus 1 is minus sine 1. We can remove the limit sign here because there is no x. Minus sine 1 upon minus 1. So this minus becomes plus, and the left hand limit is equal to sine 1. Okay. Now let's examine the right hand limit. Right hand limit upon x as x tends to 0 from the right hand side. And when x tends to 0 from the right hand side, you see, from here, x can be 0.1, 0.2, 0.001. Now the greatest integer which is less than x, say 0.01, is 0, right? Correct? So it will be sine right? Now this is equal to 0, it is given to us. So our left hand limit is not equal to right hand limit. Our left hand limit is not equal to right hand limit. Therefore, limit as x tends to 0 does not exist. Right? Thank you. We'll stop this video here. Thank you.